Functional analysis. Just today we'll discuss about the functional analysis. Some points or some definitions we can remind, and just we'll discuss. Actually, what is the functional analysis? What is the vector space? Direct product, direct sum, linear transformation, subspace, improper subspace, proper subspace, intersection of subspaces, etc. We'll discuss all those things. One question here. Question number 1. That is a Banach limit. A Banach limit is any linear functional is any linear functional L defined on M. L defined on M. For M is a vector space. M be the vector space of all bounded sequences. Be the vector spaces of all bounded sequences. All bounded sequences. Of real numbers, then following is true of real numbers. Real numbers, then which of the following is true? Then which of the following is true? So here some options are given us. That is, first is Lx greater than equal to 0. Lx is greater than equal to 0 for all if xn is greater than equal to 0 for all n. That is one condition is given. Second condition, that Lx equal to 0 if xn greater than 0 for all n. Third number question, Lx greater than equal to 0 if xn equal to 0 for all n, and none of these. Next question is, option is none of these. So which one is true actually? A Banach limit is any linear functional L defined on M, and M is a vector space for all bounded sequences of real numbers. Then according to definition you can follow. There are some conditions of definition of the Banach space. So Lx must be greater than equal to 0. First option is satisfied. Lx is greater than equal to 0. Definition from the Banach space, we know that Lx must be satisfied greater than equal to 0, or there are three criteria of Banach spaces. First is Lx greater than equal to 0 for all x greater than 0, or Lx is equal to L alpha x, and that is alpha x represented here. What is the alpha x? Now, there is alpha x is represented here, x1, x2, alpha x, so delta x1, x2, etc. And Lx is equal to 1. There are three criteria must to satisfy the Banach space. But which of the following is true from this question? That is, one is true, because from definition it is said that Lx must be greater than equal to 0. Then second question, question number 2. Question number 2 for the functional analysis is that a Banach limit is any linear functional L. A Banach limit Is any linear functional? Is any linear functional? Is any linear functional L defined on M? Defined on M. M be a vector space. M be a vector space. M be a vector space of all bounded sequences of real numbers. Of all bounded sequences of real numbers. Bounded sequences of real numbers. See, bounded sequences of which one is true is asking here. Which one is true? Which one is true? Just you follow. So some options are given below. Lx, that is equal to L delta x. Condition that where delta x is equal to delta into x1, x2, that xn. Second option is that Lx is equal to 1. If x is equal to 1, 1, that. Third condition, option both first and second. First and second, see. So just, and last option is the none of these. So that is also which one is true asking us. So we have already discussed in previous question 1. The definition of Banach limit is telling us that Lx greater than equal to 0 for all xn greater than 0. Second condition, Lx is equal to L delta x or delta is equal to delta x and Lx is equal to 1. X is equal to 1, 1, 1, dot. So both, this is the true for both the equations. A Banach limit is a linear functional L defined on M, where M is represented in a vector space of all bounded sequences of the real numbers, which are is true for both the condition. That means Lx is equal to L delta x and Lx is equal to 1. Both are considered. That is the third view is true. In question number 3, I'll discuss now. Question number 3. Question 3. See, M be the sum, M be the vector space. Let M be the vector space. See, let M be the vector space of all bounded sequences. Of all bounded sequences. Just discuss. M is the vector space for all bounded sequences of real numbers. Of real numbers. X belongs to M. X belongs to M is that. Is called almost convergent. Is called almost convergent. Almost convergent. The small x belongs to M and that is called almost convergent, and the number S is called F limit, and the number S is called F limit. Is called F limit. See, S is called F limit. If F limit of X if which condition is satisfied. So some conditions are given here. That is first condition, Lx is equal to S. Lx is equal to SC for all Banach limits L. For all Banach limit L. Second question, Lx greater than S. Lx greater than S for all Banach limit L. All Banach limit L. Then third bit, Lx less than S for all Banach limit L. And fourth bit, none of these. Just to look out here, which one is true, which condition satisfy. That from definition of F limit and convergence, almost convergent or F limit, just telling us, just remember the definition, a Banach limit is any linear functional L defined on M such that satisfy the condition Lx greater than 0. That is the Banach limit. To check which one is true for this condition. And that is true for which condition? Lx is equal to S, Lx greater than S, or Lx less than S. Which one is true? Lx is equal to S is Banach's limit L. That is almost convergent satisfied. Right here, only first bit is there. According to definition, we found that this one is true. Lx is equal to L for all Banach limit of L. X is satisfy these conditions. Then question number 3, and we come to just question number 4. Question number 4. Question number 4. Improper subspace of a vector space X. Improper subspace. Improper subspace of a vector space. Of a vector space. Improper subspace of vector space X are, what are the improper subspace of vector space X are? Just you can look what is the first option is there, X only. What is the second option is there? Null vector space 0. Null vector space 0 of X only. Null vector space 0 of X only. Third bit, X and null vector space of X. X and null vector space. Null vector space. X and null vector space 0 of X. 0 of X. Last option, none of these. Just see. So which one is the improper subspace of vector space? Just you remember the definition of the improper subspace of a vector space. So what is the improper subspace? That is the X and null vector space of X. X and null vector space of X. 0 of X. That is the improper subspace. So third bit is true. So which option is true? Now that is third option is true. That is question number 5. Just come to question number 6. And question number 6 is that question number 5, not 6. Just will come to question number 5. Just remember proper subspace of vector space X. Proper subspace. Subspace of a vector space. Of a vector space X is. What is the criteria? Now, y sub first option is that y subset of X. Y subset of X and y is not equal to X. And y is not equal to 0. That is first option. Second option, y subset of X and y is equal to X. Y is equal to X. And or y is equal to 0. Or y is equal to 0. Third option, y subset of X and y is not equal to X. Y is not equal to X. But y is equal to 0. But y is equal to 0. And last option is none of these. None of these. That is the last option. So first you check definition of the proper subspace of a vector space X. The proper subspace of vector space X is saying that y subset of X and y is not equal to X and y is equal to 0. Y subset of X, y is not equal to X, but y equal to 0. That is saying us. So third option is true. Y is subset of X and y is not equal to X and y is equal to 0. So according to definition, this option is true. So just question number 5 and question number 6 will come. Question number 6. The following y is equal to intersection y alpha such that alpha belongs to A. Alpha belongs to A. Where y alpha, alpha belongs to A is a set. Alpha belongs to A is a set of subspace. Set of subspace is a set of subspace of X. Referred as just refer as intersection of subspaces. First option, intersection of subspaces. Second option, union of subspaces. Union of subspaces. Third option, disjoint intersection of subspace. disjoint, intersection of subspaces, intersection of subspaces, intersection of subspaces. And fourth option, none of these. Disjoint union of subspaces, disjoint union of subspaces. See, so which one is true according to definitions? Y is equal to intersection of y alpha, where alpha belongs to A. Alpha belongs to A is the set of subspace of vector space X, which therefore does the intersection of subspace. That is first which is true. Intersection of subspace of vector space. Question number 6 is there. Then question number 6 and question number 7. Now just come to question number 7. The subspace generated by S. The subspace generated by S. Generated by S. The subspace generated by S of a vector space X, of a vector space X. Then which one is true? First option, X is the smallest subspace of X. Is the smallest subspace. Is the smallest subspace of X that contain S. That contain S. Second option, B, is the largest subspace. Is the largest subspace. Is the largest subspace of X that contain S. That contain S. C is the largest subspace of X that does not contain X. Is the largest subspace of X that does not contain S. That does not contain S. That does not contain S. Is the largest subset of that does not contain S. So which subspace is true for this condition? So just generate subspace generated by S you can follow. So according to subspace generated by S, that is S subset of X, that is was one condition, X must be subset of X. The subspace S generated by S is the smallest subspace that contain X only, that is smallest. A option is true. From definition, this is true. Smallest. The subspace generated by S of the vector space X is the smallest subspace of X that contain S only. Okay, then the next question, question number 7, that is question number 8. Now just to come into question number 8. The subspace YZ, the subspace YZ of a vector space X, of a vector space X are disjoint. See, the subspace of YZ of vector space X are disjoint if, what is the condition? The first option is that Y intersection of Z is equal to 0. B option, Y intersection Z is equal to X. C option, Y intersection Z is equal to Y. D option, Y intersection Z is equal to Z. So which one is true here? Just look out Y, Z, one of the subspace of vector space X are disjoint. That means Y intersection Z is 0. Disjoint, that means Y intersection Z is 0. That is disjoint subsets. Y intersection Z is 0. So option A is true. That is question number 8. And just come to question number 9. Just you come to question number 9. Question number 9. Just look out here. If L is a Banach limit, if L is a Banach limit, N is a Banach limit, N is a Banach limit, then which one is true? First option is that limit xn, lower limit, less than equal to xn, Lx less than equal to lower limit xn upper limit for all x belongs to n. Second option, Lx less than equal to upper limit of xn less than equal to limit lower limit xn for all x belongs to n. Then seek option, limit xn upper limit less than equal to lower limit xn less than equal to Lx for all x belongs to m, and D, none of these. D, none of these. So which one is true? If L is in a Banach limit L, the lower limit less than equal to L less than equal to upper limit. That is the definition from we collect. Then option A is true. Option A is true. If L is a Banach limit, the limit lower limit of Lx xn equal to this. Then this is A option is true. Question number 10. Just to discuss question number 10 now. Question number 10 is that X is almost convergent if X is almost convergent. Is almost convergent. X is almost convergent if Which condition true? First option, P dash X is equal to P of X. And B, P dash X which is greater than P of X. P dash X less than P of X. And none of these. None of these. Just you can check here which one is true for this condition. X is almost convergent if P dash X is equal to Px is true. That is definitions. 10 number questions. X is almost convergent if it is satisfy the condition P dash X is equal to Px. That is, you can say that the almost convergent. Okay. And today only 10 questions we will discuss. Then next class we will discuss another one. Okay. So thank you to all.